All right, so we are going to get started today. We are talking about a couple of things that we had an issue with. We had a problem with our lab. Well, I say we. I've looked at some of the lab reports, and I see a lot of people that didn't follow the directions. They missed steps, and there's some information that we need to go back over. So I'm going to look at that, and then we are going to be taking notes today over Chapter 2, Section 4. We're going to be talking about using position time graphs and what some different things on those mean. Okay, so to get started, I want to look at this lovely lab report that people messed up. Okay, so when we were going through these labs, I really tried to hit on the importance of making sure that you're actually following the directions. So one of the directions I saw a lot of people miss, especially when they got into part 2, which was one of the most important parts. Let's see. Okay, so we were looking at part 1, and we did all of that, and I talked about what we needed to do, and then we get down to part 2. So we made a new position match. A target graph was displayed. What a lot of people skipped out on doing was writing down how you would walk to reproduce the target graph. So that's one of the most important parts of the whole lab, is that you're making that prediction of what you're supposed to be doing. So if you had a graph match that looked something like this, and your target graph was like this, and then this, and then this, and then this, what I needed to hear from you is that you're going to start like 1 meter away from the wall. During this time from here to here, you're moving away from the wall. During this time, you're moving towards the wall. During this time period, you're moving towards the wall faster. And then in this last part, you were moving away from the wall again. So I needed to hear see your predictions. Now, your predictions weren't necessarily going to be right, but I needed to see that you wrote down your predictions. I gave you space on your page to write the predictions down. So it's on like what, the 6th or 7th page of the lab is where we did the part 2 data. So supposed to describe in words. So what I was seeing a lot of is people saying we moved backwards, we moved forwards. But there's more going on. I want you to actually write full predictions. So I'm going to check these labs tomorrow, and I want to make sure that you actually had things done correctly. So if you left out the predictions, if you want to get a 100 on your lab, you need to make sure that what? You have the predictions. Now, I know you already did this, so your predictions should be pretty close to accurate, right? Okay. Well, that leads me to the next part. You were supposed to do 5 analysis questions. So after getting done with part 2, I told you that this is the important part right here. Part 2, position versus time graph matching analysis, right here. These questions. This is 1 through 5. We didn't get part 3. Y'all only did part 1 and part 2 in the lab, so you can't answer questions about part 3. Now, I know some people just started answering all the questions, but they can't answer those questions. They were just making stuff up. Okay, so if I look at part 1, it says describe how you walked for each of the graphs that you matched. Now, I told you in the lab to make a prediction. The analysis part is where you tell me what you actually did. This is not something that can be answered in 4 words. This is writing sentences. And like I said, you need to have something about each time interval. Like, I started at 1 meter and walked to 2 meters away from the wall in 2.5 seconds. Then I went from 2.5 meters to 2 meters in 4 seconds. That's the kind of thing I want. I don't want people to just write down, we walked back and forth, because I'm going to say, you got a 0. Y'all understand? Yes, ma'am.
Okay, I'm going to explain about how it's supposed to be done.
Mm-hmm.
Can we redo it and put it in your advisory?
No. Can't redo it. I gave y'all 2 days for a 15-minute lab. And I gave you all these instructions before we started. So we can't do it again.
Did you just say, like, you can do the questions and just turn it tomorrow?
I
I'm talking about the describing of the answer.
told y'all are turning these in tomorrow.
Then what's she talking about then?
No, I'm talking about the describing of the answer. Like, if you describe it wrong, can we do
Yeah, fix it. You're turning it in tomorrow.
But she already said that, though.
Why?
All right. It says explain the significance of the slope of a position time graph. Now this is going to tie into what we're actually doing today. So what did y'all figure out the slope meant? How steep the slope was what? How fast you were going. Now, positive and negative, what did that tell you?
Which way we going?
Which way you're going. It's telling you direction. So that's what we're going to be talking about in class today. Okay? And then you should be able to answer questions 3, 4, and number 5 we talked about in the preliminary questions. I think some people didn't quite do number 5, where it says test the answer to this question using the motion detector, but you can answer the question part first. Okay? So again, I'm giving y'all this because I want y'all to be successful on this lab part, and I know that there's a lot of people that won't be if they don't go back over their work. Okay? Labs are important grades. There's a reason why I give you so much time on them. It's because it's where you're actually supposed to put the knowledge that you're learning and the real world together. You've got to mix those two things, otherwise things don't stay in your brain very well. All right. For pre-AP, y'all also did part 3, so make sure that y'all are doing everything the way that you're supposed to. The rest of y'all can stop at that number 5 right there. Okay, so now we're going to go on to our notes for the day. So what we're going to do is I'm going to open up the essential questions, and I'm going to give y'all a couple minutes to copy them down. Make sure that you're putting these in your notebook. This is Chapter 2, Section 4. We are talking about how fast something is. So, like I said, I'm going to go ahead and give y'all a couple minutes right here. And the microphone's going dark. Just about one more minute. All right, time's up to write those down. Go ahead and move on. Okay, so we're going to consider the position time graph of two runners. So that's what's showing up over here on the screen. Now, the slope of a position time graph for an object is the object's average velocity. That sounds like something that's kind of important. Slope of a position time graph is the object's average velocity. So that seems like we, if I went through the trouble of underlining, I might want to write it, right? It might even be like the third essential question. Okay? Well, at least part of the third. The other part of the third essential question is right here. This formula that goes along with it. So V bar, V with a bar over the top of it, is average velocity. And then you got this little 3 arrow thing here. Y'all see, or 3 lines instead of just 1 line? That means that it's defined as. So average velocity is defined as this. Delta x, we know delta means final minus initial, divided by delta t, which is final minus initial. Okay? So we've got a formula to make this thing work. Bless you. Now, what's the other thing I usually put in parentheses whenever I define one of my variables? Well, I usually put what the unit I'll typically see is. Remember, I usually put the unit, so this is the position or the displacement, delta x, which was in meters, divided by the time, which is usually in seconds. So typically, if you see something with a meters per second, that means that you're talking about velocity. Okay? So all this formula is really telling you is that you're calculating the slope of the position time graph. Remember, slope is rise divided by run, correct? Which y'all usually did was y2 minus y1 over x2 minus x1, right? Okay, so if I look over here, my y-axis is called position. And instead of putting 2, they put final. So over here minus over here. So that's the same thing as y2 minus y1. And then our x-axis is going to be time. So the second one is the final minus the initial one, which is the first one. So it's the same thing as calculating slope like you did in algebra, but we're actually going to be calculating slope and having a formula. Fun thing about formulas is you can use them in other situations. Okay. We're going to go on to the next part. So we got average velocity, right? Okay. Now, we talked about this in the lab, and y'all already told me that y'all know this from talking about our lab. The sign of the slope tells you direction. So the sign of the slope tells you direction. There we go. That way I don't mark out the words. So, for instance, if I got a positive for my slope, it means I'm moving in the positive direction. If I got a negative, it means I'm moving in the negative direction. So, way back, like 2 weeks ago, we talked about our typical positives and negatives. We did our little coordinate system right here. And we did it looking like this. We had this, and we had this. So if it's positive and to the right, we said it was to the east. If it's positive and moving up, it's, you know, those are things, like all of these things are positive. North and east, up and right, counterclockwise, all positive. Okay? So, like in our lab, positive meant moving away from the wall. So if I had a positive slope, it meant that I was moving with some speed away from the wall. If I had a negative slope, it meant I was moving with some speed towards the wall. Okay? Oh, we got another definition in here. The slope's absolute value is the average speed. So we have V bar was called average velocity. We wrote that down just a second ago, right? Now, if I take the absolute value, so that'd be the absolute value of V bar, this one's going to be called average speed. So what did I do mathematically by putting this absolute value sign on there? I made it to where you can't tell positive from negative, right? Well, speed is just like velocity, except it doesn't have a direction. That's the big difference. That's why your car has a speedometer, it doesn't have a velocity meter, right? Yeah. It does. Like, you look at your speedometer in your car, it doesn't say you're going 65 miles an hour north, does it? No, it says you're going 65 miles an hour. When appropriate, never speed. It's not good. Okay. The last thing we already talked about this word instantaneous, right? Instantaneous means what? At an exact time. So like I could say the instantaneous velocity right here, and it's whatever the slope is at that exact point. Now to really get that slope, you would probably need some calculus. But what we can do is we can take the points really close to it and calculate the slope, and we'll get what it is there. Or if we're lucky, you end up with things like this, where we have a linear relationship, and then the average slope is the instantaneous slope. So the average velocity would be the instantaneous velocity. Okay? We have any questions at this point? All right, so next thing we're going to do is an example. So our example problem is, what is the average velocity of an object whose motion is represented in this graph? And then what is the average speed? So in this class, we use the guess method, right? So we got to look at our givens. Well, what are our givens? Y'all see any givens? I don't see them. And they got so many givens on here, you can't even see them. Well, they gave you a whole graph. That's your given. So on this graph, what I'm going to do is I'm going to pick two pretty points. So this one right here is a pretty point because I can tell exactly where it's at. It's at exactly 50.0, and the time is 0.0, right? And I'm going to choose this as my other pretty point way down here, because I can tell that it's exactly at 25.0 on time, and that my distance or position is 0. So what I can write is my x initial and my t initial, my x final, and my t final. Okay, so this is my initial point. Why did I choose this as initial? Because it's closer to time 0, right? I know that something I've seen a lot is people that will try to use the further away one as the initial because it's closer to this axis, but really initial's over here. Does it matter? Not really. As long as you put your numbers in correctly, you'll get the same thing. That's like if you calculate the slope between 2 points, it doesn't matter which point goes first as long as you put it into the right spot in the formula, right? Okay? So my x initial in this case is going to be 50.0 meters. My t initial is going to be 0.0 seconds. My x final is going to be way over here, right? 0.0 meters. And my t final is going to be 25.0 seconds. Okay, so what are my unknowns? My unknown is the Average velocity is the first thing, v bar, right? And then after that, what is the average speed, which is just the magnitude of v bar, right? Okay, well, my equation for v bar is v bar equals x final minus x initial over t final minus t initial. So then we can go to solve. Well, x final was 0 minus x initial was 50 over t final was 25 minus t initial was 0. So that's 50 divided by 25, right? Well, negative 50 divided by 25. Sounds like I'm going to get 2.00 unit meters over seconds. Okay, well, what does this negative represent? Negative direction. Okay, it didn't tell me that it was up or down or anything like that, so what I'm going to write as my answer, I always have to say what my answer's direction is. So I'm not going to include the negative here. I'm going to say I got 2.00 meters per second in the negative direction. So that's that. Okay? Ooh, I should have labeled that. That's v bar. Okay? The last part, how do I get my average speed? Well, I'm taking the absolute value. So absolute value of negative 2 is? So I can just say that it is 2.00 meters per second. That's my average speed. That's it. Do I have any questions? Comments? Concerns? Y'all got this? Those are my two answers. So my average velocity was 2.00 meters per second in the negative direction, and the average speed was 2.00 meters per second. No direction. Again, velocity is a vector. It has magnitude, this number here, and it has a direction. Speed is a scalar, so it just has magnitude. Both of them have units. Don't forget your units. All right. Go on to the next little piece. Okay, it says, recall that a straight line can be represented by the equation y equals mx plus b. Y'all familiar with that equation? Yeah, slope-intercept form, right? Well, we can rewrite what we had before as an equation. So the graph of a straight line on a position time graph can be represented by this equation. This is an important equation. And that's really saying that x at that instant, so sometimes you'll see this written as x final as well, is equal to v bar, which is our average velocity, times delta t or t. I'm just showing y'all the different ways that you might see this written, plus x initial. So this is another way that you'll see this written. Well, the y variable of our graph is position, which is x in physics, right? The slope of our graph is the average velocity, v bar. The x is our x final, or I'm sorry, the x on our graph is time, and the intercept is where it initially was. So that's how we end up using that same thing. I have questions here? No, y'all good? Oh, I need to wait for writing. Okay. Let me know when you're done writing. All right. can change the hand? No. Oh, yeah, there it is. Yeah. You can do some settings on your computer. All right. We got another class example. So this is going to look like example problem 4 in your textbook. Okay, it says a car is initially 6.0 kilometers east of the origin. It drives west at a speed of 12 kilometers per hour. What is its position after 1.2 hours? So again, we're going to use the guess method given. We had initially, that's going to be a hint right there. That's our initial position, is 6.0 kilometers east. Okay? Now let's make sure that we take this east and tell it what it is. Remember, direction is just positive or negative, right? So east is positive on our coordinate system. So that means we're just going to have 6.0 kilometers. Okay? And it says it drives west at a speed of 12 kilometers per hour. Now, they told us speed and direction, so what did they really tell us? That's right, velocity. So my V bar is going to be 12 kilometers per hour to the west. That's right, and west tells us that it's actually a negative 12 kilometers per hour. And the last thing it gave us was the amount of time it took, which was 1.2 hours. I don't know why I put an R on it and I put an H on it up there. Okay? Our unknown is what is its position after 1.2 hours? So what is the x final, or what is the x, depending on how that equation was written before, right? All right, so we're going to write the equation. I usually write x final because I think it makes it easier for you to see where you're going. But if you want to just write x, that's fine. So x final is equal to v bar times the amount of time that it took plus the x initial. So the final position, x final, equals v bar, the velocity, times the amount of time that it took, plus the initial position, xi. All right. So now we just solve x final equals negative 12 times 1.2 plus 6. All right, so we do a little bit of mathing. We get x final equals negative 14.4 plus 6. So that means x final is equal to negative 8.4. Okay, I'll believe you. I ain't got the math calculator to check right now. It's negative 8.4. Okay, good. Whew. My brain was not working right for that one. So I got negative 8.4. Now I need to convert this into something with a unit and a direction, right? So the negative means that it was going to the west. And I had 8.4. Come back over here. What was my x in this time? Kilometers. So x final is equal to 8.4 kilometers west of the origin. And that's how we do that right there. Okay? Do I have any questions on this? All right. I am not going to give you any homework tonight because I know that some of y'all need to go back and refinish the stuff on your lab. And some of y'all need to finish some homework that you haven't finished yet. We're going to have a test Tuesday of next week over this. So y'all better make sure y'all getting caught up. Now, we're not done yet because we still got to do one thing. We got to review these essential questions and see if we can figure out what things are. Can somebody tell me what is velocity?
Velocity is the slope of a particular time.
Okay, slope of a position time graph. And what does it really represent? Give me another word than speed. What is speed telling you something's doing? How fast something is going. There we go. That's what I was looking for. So velocity is the slope of a position time graph, and it tells you how fast something is going. Okay? What's the difference between speed and velocity? That's right. Speed will just tell you how fast something is. Velocity tells you how fast it is and in what direction it's going. So another way of saying that is that speed is a scalar and velocity is a vector. Wonderful. Yes, velocity has how fast you're going and what direction you're going. Okay? Now we have, how can you determine an object's average velocity from a position time graph? It's the slope. So if you have a position time graph, you can calculate the slope. Another way to calculate the slope is to just use the formula that we wrote down, right? Yeah. Okay? And it says, how can you represent motion with pictorial, physical, and mathematical models? So now that's something that we've had on multiple times this time, right? So we can represent our motion by drawing a motion diagram. That's a picture model, right? Yeah. A physical model, we could have people actually go and run it, right? Yeah. And then mathematical models like a position time graph, because that's a mathematical model. All right. That is it for the notes today. Make sure that y'all are studying. You're going to have that test coming up. And, yeah. One big reminder. Today, Thursday, September the 13th, 2018, there is no tutoring after school. I will not be here. I can see you on Friday morning or Friday after school. Have a wonderful day.